wondered why some volleyball spikes are faster and more powerful than others?
When a player performs a spike, a force is applied to the volleyball, causing it to move quickly towards the opponent's court. In physics, force refers to a push or pull acting on an object, while acceleration describes how quickly an object's velocity changes with time. This situation can be explained using Newton's second law of motion. In this presentation, we will discuss the relationship between force and acceleration during a volleyball spike and see how these factors affect the speed of the ball.
The objective of this study is to investigate the relationship between force and acceleration during a volleyball spike. According to Newton's second law, acceleration is directly proportional to the applied force and inversely proportional to the mass of the object. This means that a greater force will produce greater acceleration if the mass remains constant. Before we continue, let us consider a few questions. Does applying a large force produce a faster spike? How much acceleration is generated during a volleyball spike? How does acceleration affect the velocity of the volleyball? To answer this question, we use a simple case study and apply basic mechanics calculation.
Let's consider a volleyball player performing a spike. We assume that the mass of the volleyballs is 0.27 kg. The initial velocity is 0 meter per second. The final velocity is 25 meter per second, and the contact time between hand and ball is 0.1 second. Our objective is to calculate the acceleration of the volleyball and the force applied during the spike. Step 1 is to calculate the acceleration. We're using the formula A equals to V minus U over T. Then, we substitute the value into the formula and we get the final answer, which is 200 meter per second square. Step 2 is to calculate the force. Using Newton's second law, which is F equals to ma, we substitute the value into the formula, which is m equals to 0.27 and a equals to 250. Then we got the final answer, which is 67.5 Newton.
Based on our calculation, the acceleration of the volleyball is 250 meter per second square, while the force applied during the spike is 67.5 Newton. This result supports the Newton's second law of motion, which states that greater force produces greater acceleration when the mass remains constant. So, now let us answer the question raised earlier. First, does applying a larger force produce a faster spike? The answer is yes. A larger force generates greater acceleration, allowing the volleyball to travel at a higher speed. Therefore, stronger and faster arm movements can produce more powerful spikes.
Oh my god! Wow!
Second question. How much acceleration is generated during a volleyball spike? From our calculation, the volleyball experienced an acceleration of 250 meter per second square during the spike. And finally, how does acceleration affect the velocity of the volleyball? The answer is the acceleration causes the velocity of the ball to increase from 0 to 25 meter per second in only 0.5 seconds. Hence, greater acceleration results in a faster moving volleyball. In conclusion, this study successfully applied mechanics principle to a real-life volleyball situation. The findings show that applying a greater force produces a faster spike. The acceleration generated during the spike is 250 meter per second square, and this acceleration increases the velocity of the volleyball from 0 to 25 meter per second. These findings are consistent with Newton's second law of motion, which explains that force and acceleration are directly related when the mass remains constant. Therefore, understanding this concept helps explain how powerful volleyball spikes are produced and highlights the importance of physics in sports.
That's all from us. Thank you for watching. Bye-bye.
Okay, that's all from us. Sekejap. That's...
So tak kata tak
Aida.
cakap sebab
Okay,
nanti dia
okay.
dengan punya hujan lagi.
Okay, now, based on tak payah now tu tak payah. This study successfully applied mechanics principle. Okay. Yeah, habis.
I just had to let you know you're